site called Laetoli in Tanzania. And this trail of footprints is about 80 feet long, and it represents 2 individuals that walked along the surface, and then one individual came behind, and the footprints on this side, you'll notice, are larger. And then they're not actually larger. If you look closely at them, they're double prints. So the individual that came behind on the right actually put its feet in the footprints of the one that went before. But these are clearly made by a biped, and they're clearly made by an ancestor that didn't walk so very differently from us. So I decided to try and bring the record back older than afarensis. Afarensis was between 3.3 million years. So I was looking for a site that would extend it back older than that. And I knew one site known as Canopy that's 4.2 million years old. And I was hoping that I would find evidence of some different species, and also one that maybe was also walking on 2 legs by feeding it. When we look for fossils, we do it exactly the way it's always been done all over the world for centuries. You just walk and look at the ground. In most sciences, modern technology has made it possible to do things more quickly, to do things more efficiently. But there's no way, that's the only way. And it's very slow, it's very tedious, and it takes a lot of dedication. And the team of people that we have doing this are really very good at recognizing bones, knowing what they're finding, and they're out in the hot, hot sun for hours and hours and hours. So a lot of people said to me, surely there's some remote sensing system that you can use, or there's something that you can develop. Louise, at the moment, is trying to take high-resolution imagery that she can put on the web and have kids look for their own fossils on this imagery. So she's got a crew coming up with a remote-controlled helicopter in May to try and see if it might be possible to do something like that. But basically, there's no way that you can speed this up, I don't think. But if you could do it on the web, I guess it would be another way. If we find something, then we screen the surface, and this is what we do. We take all the surface soil, put it through these screens, and then look through the screens to try and find more pieces of bone. And this is how we find all the extra pieces of a skull like 1470 and so on. This is what you see as you walk along the surface. And really, you don't see much bone. But every now and then, you're lucky, and you find something. So I put this thing, can you see a fossil in the middle of that picture? Isn't it not easy to spot? But I've made it easier for you. This was found by one of our crew one day, and when we excavated it, we have this beautiful mandible here. This is a lower jaw, and there's some of the teeth of another individual. And the specimens we found that first year in Canopy showed us clearly that we had something that was different from Lucy, and that it was older. So here we have now a species that goes back to 4.2 million years, that is more primitive than Lucy. But unfortunately, everything about this species, which we call Australopithecus anamensis, ana means lake, everything about that is just more primitive than Lucy's lake, could still be on this single line. And what worried me about this whole picture or theory is that every other angle you look at, it evolves through radiations and then pruning of those radiations. And here you have this straight line for our ancestry, and I just don't believe it's possible. So when we looked at afarensis and we found that it was just a primitive, when we looked at anamensis and found it was just a primitive afarensis, it didn't really show what I was trying to show. However, what's happened? Sorry about that. But one thing we did find was this bone here. And this is a lower leg bone. It's known for tibia. The proximal end, the end by the knee is here, and the end by the ankle is there. And looking at this bone, it's clearly from a bipedal animal. And so we could tell, because if you look at a chimpanzee's tibia, because the chimpanzee walks on 4 legs, the bones are not nearly so strong. A human tibia is a very strong bone with a big, broad shaft, and a chimpanzee will waste very, very sharply under the knee joint and above the ankle joint. So this was clearly from a biped, and so this is good evidence for bipedality over 4 million years. So we had, that was one of the big finds that we found at Canapoy as well. While I was working at Canapoy, Louise had just got her pilot's license, and she was trying to catch her hours up, because when you're a young pilot, nobody wants you to fly their aeroplane, obviously, because you don't have much experience and nobody trusts young pilots. And so she was having trouble trying to find somebody's plane that she could fly. And Richard's brother, Louise's cousin, had just learned to fly as well, and Richard's brother had bought this little aeroplane for Nigel to fly. So Louise persuaded her uncle that she could fly this, and so Louise and I used to fly backwards and forwards to this side. And we had some real adventures. The worst one was when halfway up the engine started coughing. We were miles from anywhere. There was, I mean, literally there was no water, there were no villages, there was nothing. In a very, very remote part of the country. The engine, so Louise said, let's go straight as fast as we can. And we just were coming into land and the engine completely cut. With fuel pouring out of the engine, we let out, and then later got an engineer out, and only to find that the carburetor was full of beetles. It had just been serviced in Nairobi, but obviously somebody had taken this brand new carburetor off the shelf, put it in the airplane without looking inside it. So I consider we were lucky on that occasion. Louise now is a very experienced pilot. She flies back and forth the whole time, and she's a great asset, because to drive to this remote area is 2 or 3 days. To fly is 2 or 3 hours, depending on how far you're going. But it makes a big difference. And so to have that airplane, we have a project airplane we fly, or Louise flies, backwards and forwards, and it's wonderful. And she's an excellent pilot. So back to the work, when she joined me as co-leader of the expedition in 1998, we decided that we would move further north and still try and show whether human evolution was actually a straight line, as you see on the left, or a tree situation, or more of a bush situation, with a lot of radiations going back in time. But we had to find another species, and to go alongside these two, or even further back in time, to get more diversity in the record. So we went to this site called Mackin, where we found some colonies in the early 80s. So we knew they were there, and we started working there. It was on the west side of the lake, and a beautiful site. We worked for 2 years. The first year we found a number of isolated teeth, but nothing that you could say was a different species. And then the very last week in 1999, we found this piece of upper bit. We found this rather marshaled bone in situ, which was clearly an ancient human skull, but it was in a clay deposit. Clay expands and contracts with the rain and dry, and anything in it then becomes cracked and broken up, and this was no exception. So when we finally excavated all the bits, and we sieved and found everything we could, we had this just mass of tiny fragments and distorted bone. It was a nightmare, to be honest. But with the expertise of one of the museum preparators, we got it all cleaned up, and here we have a really interesting specimen, because it's a fossil skull which is quite different from Lucy, from Afarensis, from Animensis, and appears to represent a separate lineage. It has this very flat face, and it's very different, as you can see, from Afarensis. But now we can see that we actually do have a choice of two different things early on that could be the common ancestor. And I'm sure as more and more work is done that we're going to find more and more. So we've been publishing in various numerous journals. A number have been covers on Nature when we find new exciting finds. And we've also published a number of monographs and other publications. It's just a long-term project that's going to keep going way into the future. And so Richard and Louise and I have been concerned about keeping the research going and making sure that it goes on into the future. The story of human evolution in the last 40 years has changed from this very simple picture of Lewis's to a much more complicated, complex picture that we have today. And with every find it's changing and more questions are answered. But in order to make sure that the research continues in the area in the future, it's a very remote area. It's very hard to get there. It's very hard to work there. And most expeditions have traditionally been run from Nairobi. And so what we're developing now is what we're calling the Turkana Basin Institute. And it has an office in Nairobi and 2 research centres on either side of the lake. The idea is that we'll facilitate research, but we'll also at the same time do a lot of education in terms of educating young Kenyans to be scientists in this field or in other fields, to educate the local population and to understand their heritage, and to engage local communities and things we're doing and to conserve and preserve. The 2 centres are on the west side and on the east side. The west, as you can see here, is complete and is now functioning and running efficiently. The east side is under construction at the moment. But we've had several conferences now, for annual conferences that we hold on these subjects, and other people come in and run conferences as well, because being in such a remote area with no interruptions from telephones and things like this, you have really intimate conferences where you get very, very good discussions going. People run their expeditions from the Turkana Basin Institute now, so they can fly out, hire cars, tents, personnel, field workers, and all sort of thing, and do everything very, very much more efficiently than could ever have been done before. And it's proving to be really working the way that we'd hoped. We run a field school, so twice a year on the west side at the moment. We'll eventually run it also on the east side. Twice a year in the spring and in the fall. We have a 10-week semester field school that covers 5 2-week modules. So we have geology, modern ecology, paleontology and paleoecology, archaeology, and anthropology, paleoanthropology. So the students get an amazing experience that they would never get in their own university, and they all get extremely enthusiastic. Here you can see them doing some modern ecology, and at the bottom there they're learning how to make stone tools at the Research Centre. We also do, we're affiliated with Stony Brook University, which has helped enormously on the education side, and we offer postdoctoral fellowships and undergraduate fellowships to encourage African students to keep in the field and not just to go off and get a job in America and not at least if they work in America, they can continue to do their research in Kenya or in the Turkana Basin. And so we've had a number of postdoctoral fellows now, and there's undergraduates as well. We're training local people, so the local people now are fully participating in the work. So they find the fossils, prepare the fossils, collect the fossils, do the work in the lab, and curate the fossils. And we're developing really good teams on both sides of the lake now to do that. We bring in groups of school children from the local community so they can see what we're doing and learn what we're doing and understand their heritage and how important it is. And we're also running a number of community services This is a mobile health clinic that we have on the east side of the lake, and we're also we put up clinics. The maternity clinic we just put up close to the centre on the east side, on the west side. So there's a number of community projects going on as well. If you want to find all the details, you can go to our website, which is turkanabasin.org, and it explains all the details that we do. So why is this subject important? Why is it something that we feel is important to humanity's future? And I think it's looking into the past really gives you an idea of the present and the future. If we didn't know anything about our past, we would imagine the world would always look a bit like it does today, which of course it doesn't, and it hasn't. The world we now know goes back at least 3.5 billion years, or at least life on the world. The world itself goes back longer. But 3.5 billion years ago, there was life on this planet. Homo sapiens has been here for just 200,000 years. The earliest Homo sapiens actually comes from the Turkana Basin. Richard found a skull in 1967, actually 2 skulls, which are very early evidence of our own species. 200,000 years ago is nothing compared to 3.5 billion. Human migration out of Africa, the Homo sapiens migration as opposed to the Homo erectus migration, was just 65,000 years ago. And it's believed that that every single person on Earth comes from a population in Africa of about 2,000 people only. So that everyone can trace their genetic ancestry back to this population of 2,000 people. And through genetics, through languages, and through some of the fossils, you can trace the path of humanity outside Africa, and the timing as well. So from 65,000 to a mere less than 15,000 when humans got to America, people gradually spread all over the world and now occupy pretty much every corner of the earth. But in that 65,000 years, human population has gone from just 2,000 people, in fact 2,000 figure is correct, to 250 million in 1 AD, 1 billion in 1776 when America got its independence, 2.3 billion when I was born, 7 billion today, and predicted to be at least 9 billion by 2050. That's a huge number of people, and that brings with it big concerns for the future. And I think, again, if we can put ourselves in the perspective of the past, we can sort of see that our future is not necessarily as secure as we might like to think. So the question I like to ask is a big brain a really good thing for